Hello everyone, this is Charles Betancourt for the Week 6 presentation on series parallel circuits and potentiometers. So what is a potentiometer? A potentiometer is a manually adjustable resistor with 3 terminals. They are often referred to as a pot. As you can see, I put 2 pictures there, and figure A shows an example of what a potentiometer looks like, while figure B shows what a potentiometer looks like in a circuit diagram. Now here's a little bit about the potentiometer. A potentiometer has 3 pins, as said before. 2 terminals, the blue and the green, are connected to a resistive element, and the third terminal, the black one, is connected to an adjustable wiper. Potentiometers can work as a rheostat, which is a variable resistor, or as a voltage divider. A picture shows more or less what it looks like with a wiper and a resistive strip. The rheostat. To use the potentiometer as a rheostat, only 2 pins are used. One outside pin and the center pin. The position of the wiper determines how much resistance the potentiometer is imposing to the circuit. If we have a 10 kilo ohm potentiometer, it means the maximum resistance of the variable resistor is 10 kilo ohms and the minimum is 0 kilo ohms. This means by changing the wiper position, you get a value between 0 kilo ohms and 10 kilo ohms. And there's a picture with the wiper, resistive strip, and the terminals of a potentiometer being used as a rheostat. The voltage divider. To use a potentiometer as a voltage divider, all 3 pins must be connected. One of the outer pins is connected to the ground and the other to the VCC, while the middle is the voltage output. When the potentiometer is used as a voltage divider, the wiper position determines the output voltage. When a potentiometer is connected this way, you get a circuit like the one seen in figure B. Basically, the voltage divider is used to turn a large voltage into a smaller one. The output voltage can be calculated using the following equation from Ohm's law, which is shown in figure C. Voltage output is equal to the VCC times resistor 2 over resistor 1 plus resistor 2. The potentiometer taper. One main concept associated with potentiometers is the taper. The taper is the relationship between the position and the resistance of the potentiometer. The most common types are linear and logarithmic tapers. Linear potentiometers. The simple linear taper is the most common form of taper. In a linear taper, the relationship between the resistance and the potentiometer position is linear, meaning that if the knob of the potentiometer is at the medium position, the output voltage is half of the voltage throughout the potentiometer, which is shown in figure A. Now in figure B, it shows an example of a potentiometer with linear taper. That is a real-life example of what one looks like. And note this, that potentiometers with linear taper are marked with a B as shown in the example. You see how it says B10K? That's how you know this is a linear potentiometer. Logarithmic potentiometers. Nonlinear tapers are specially used in audio control applications, known as logarithmic tapers. There is also an inverse log taper, but we won't be discussing that today. Now the relationship between the position and the resistance is shown in figure A, while figure B shows an actual real-world example of what a log taper looks like. And just like before, note that the potentiometer with log tapers are marked with an A as shown in the example. As you can see, it says AK. That's how you can tell the difference between a linear and logarithmic potentiometer. Now here are a few common potentiometer uses. Potentiometers are commonly used to, number 1, control audio volume of a radio. Number 2, adjust picture brightness, contrast, and color response in televisions. And number 3, as light dimmers. This is my references page that shows where I got my information and pictures, and I hope you enjoyed the presentation. Thank you.